So a lot of times they ask about domain and range of a function, and we've talked about that in the past. But this example has to do with how you state the domain and range from a graph. And we're going to use interval notation, and I want to talk about that a little bit. This seems to be one of the points that, for some reason, sometimes it's kind of confusing to students. And so I want to go over how to look at this. So it says use the graph of the function to find its domain and range. Write the domain and range in interval notation. Okay, so I blew up the graph so you could see it a little bit better. But how many ordered pairs are there in this function? First of all, is it a function? Does it pass the vertical line test? Yes, it's a function. It passes the vertical line test. And how many ordered pairs do you see? Well, there's an infinite number. I'm trying to draw little blue or little green dots here, but there's an infinite number of ordered pairs along this line. So if you're thinking, well, I'll just list, the values, the integers or something, you can't list them. That's why we have to use the interval notation, okay? Now, the domain, so I'll write out domain. I usually just put D for domain, but domain, and we're going to put it as interval notation. It's the x values, right? So I'll put in parentheses down here, x values. You can't list them. Now, we did that on other problems earlier in the chapter, I think. I've done a lot of videos, so I just don't remember which videos are in which class. But if there were a finite set of ordered pairs shown, we could list them. But it's representing this curve, and there's an infinite number of ordered pairs, so you can't just list the x values. So if that's what you were thinking. Okay, so that's why we have to have the interval notation. And what you're going to do is you're going to look at where is it starting. So it looks to me, and this is the part I think is a little hard to read on the graph, but it's a blue dot there. It's closed. I think it's closed. And I think it's a closed blue dot here. And I'll talk about what happens if it's open in a minute. I'll talk about that. Okay, so for x values, you're starting at -5, and I'm going to include the -5. And then it's going all the way over, there's x values, and what am I looking at? Where is the curve? So is there curve here? Is there curve here? Is there curve here? And then we're stopping. And where are we stopping? We're stopping at 1. So, comma, 1, and we're including the 1, okay? So that is the domain. Now, let's just pretend, for a minute, I'll put it back regular. Pretend that was an open dot there. Maybe it is in the book. I don't think so. I think it's closed, but I could be wrong. If it had been an open dot, then it would have been, you would have had the same thing, -5 to 1, only you would have had a parenthesis there. Okay, at the 1, because you wouldn't be including the 1, okay? But I really think it's a closed dot. Okay, so I don't want that to be confusing, so I'm going to fill this dot in. And I'm going to erase our pretend case here and say that that's the answer. Okay, now we have to do the range. Oops, the range. And it's the same thing, you can't list them. There's an infinite number of outputs, and so you have to use the interval notation. So we're looking at the y values. So I usually tell students, okay, turn your head the other way. So what we're doing is we're going from the bottom, the lowest range value, to the top. So domain, left to right, range, bottom to top. So what's the lowest range value we have? Right there at -4. It didn't switch. Oh well. -4. We'll just put it in blue. Up to, and then it's going up to, it looks like 2, right? And we're including that. I'm assuming those dots are closed. Okay, so that's how you do it. Practice those because sometimes those questions come up and it's really good to be able to list the domain and the range in interval notation. Okay?